So this is going to be a review of the second derivative test. Most of you have done this in the past, and this is sort of a review. And we'll start with this problem. Use the second derivative test to find the maximum and minimum of this function. And actually, I think I wrote that down, or there should be a plus right here. So find the max and min of x cubed plus 3x squared minus 9x plus 5. And remember, whenever you want to find the maximum and or minimum of function using calculus, we start by taking the first derivative and set that equal to 0. And so that gives us this. And we want to set this equal to 0. And we can factor out a 3 here. That's going to make it a little bit easier. Plus 2x minus 3, like this. And we can factor this. We need two numbers that multiply to give us minus 3, but add to give us 2. And so that's going to be x plus 3 and x minus 1. And then so the solution to this is going to be x equal minus 3 and x equal 1. Those are the two things that will make this 0. So now let's test each of these. So let's test. Let's do the second derivative test. I guess first of all, we have to find the second derivative. So that's going to be, it'd be easy to go back here. And so it's going to be 6x plus 6, like this. Now we want to do the tests. Plug in each of these numbers. Let's plug in minus 3 into this function. That's going to give us minus 12. So that means minus 3 has to be a maximum, because you remember the second derivative tells you how the slope is changing at the given point. So at minus 3, the slope must be changing in the negative way. So it's going from a positive slope to a negative slope. So therefore, this point is a max. So x equal minus 3 gives you a maximum. Now we can find what the value of that is. So put that back into the function, and that'll tell us what the value is at that point of our function. And we'll put that into our calculator. It gives us a 32. So again, the maximum occurs at x equal minus 3, and the function, the maximum value of function at that point is 32. And so let's actually plug this into this here, put in 1. So I'm testing the other point. I'm testing x equal 1, and that's going to give us 12. The slope, since this is positive, this is telling us the slope is changing in the positive direction. And in the case of a max or min, that means it's changing from a negative slope to a positive slope. That means this point here must be a minimum. So x equal 1 produces a minimum. And again, you can put that value back into the function and see what you actually get And this looks like 3, 4, and that'll give us -5 plus 5 looks like that's 0. So that's going to be the minimum value. So just check my numbers here. Put 1 in here, got 1 plus 3 is 4 minus 9 is a -5 plus 5 is 0. Yeah, so we have then the x equal 1 produces a minimum. So that's the basic way that you handle the second derivative test. It's pretty straightforward. You take the first derivative, set the function equal to 0, and see the numbers you get, then test those numbers in the second derivative. If you get a negative, then that means that point produces a maximum, and you'd find the value of the maximum by putting that x back into the function. If it's a positive, then that value produces a minimum.